Welcome back to it. It's Maths Master Class with Leo. Today we are doing differentiation of a product, right? We're differentiating a product rule. Differentiation of a product, right? So in our previous lesson, or in our previous video, we did introduce a little bit of this. We didn't go into detail with this. So today we're gonna do more questions on differentiating a product, right? So remember what we said in our previous class. We said, let's say a given y is equals to v multiplied by u, right? They want you to differentiate this where v and u are functions, right? Can be a parabola, can be a straight line, can be a trig function. So where both are functions, right? So in this case, when you differentiate this, you need to start by differentiating v, keep u constant, or start by differentiating u, keep v constant, right? So this, it doesn't matter as long as you'll be able to differentiate in a correct manner. So even if you start with v, even if you start with u, it's not a problem. So in this case, I'm going to start by differentiating y, which when I differentiate it with respect to x, it will give me dy over dx is equals to, and then differentiate u, keep v constant. So this will be v multiplied by u, or du, over dx, plus, then differentiate v, keep u constant. This will be u multiplied by dv over dx. Right? That is how I'm going to do it. Or let's say you're given h of x is equals to f of x multiply g of x. They want you to differentiate this. Differentiating this, it will be h prime of x is equals to f of x multiplied by g prime of x plus f prime of x multiplied by g of x. Right? That is how you're going to do it. Without any further waste of time, let's get a question. Say a given, let's see, y is equals to 3 root of x ln of 2x. They want you to differentiate something like this. How do you do that? Differentiating this, the first thing I need to do, I need to make sure that in my question, I don't have any radical signs. So I need to remove this radical sign, meaning I'm going to have y is equals to 3x to the power half ln of 2x. Right? From there, start differentiating. I'm going to differentiate this, which will give me dy over dx is equals to, from there, I'm going to keep 3x half constant, differentiate ln. When I differentiate ln of 2x, I'm going to get 2 over 2x, right? Plus, and then I'm going to keep ln constant, ln of 2x, differentiate this, which will give me 3 over 2x to the power 1 over 2 minus 1. And then dy over dx is equals to 3x to the power 1 over 2 into 1 over x plus, this is going to be 3 over 2 x to the power negative 1 over 2 ln of 2x. Then here I can further simplify, which will give me 3x to the power 1 over 2 multiplied by x to the power negative 1 plus 3 over 2 x to the power negative 1 over 2 ln of 2x, and then 3x to the power negative half plus, this will be 3 over 2 x to the power negative half ln of 2x, and then taking out the common factor, I'm going to have 3x to the power negative half into 1 plus 1 over 2 ln of 2x. That is my solution for this question. If they want me to differentiate y is equals to 3 root of x ln of 2x, this is what I'm gonna get. Or you can further simplify it again, which this will give you 3 over square root x into 1 plus half ln of 2x. That is how you're gonna do it. Let's get to the next question. Next question, let's see. Next question, let's use a blue color. You are given y is equals to x to the power 3 cos of 3x. They want you to differentiate this. So differentiating this, I'm gonna go straight to differentiating. Differentiate y with respect to x. I'm gonna get dy over dx is equals to, I'm gonna keep this constant, x cubed. Then differentiate this, which will be negative 3 sine of 3x plus, and then keep this one constant, which is cos of 3x. Differentiate that, which will be multiplied by 3x squared, right? This is a multiply, and then rearranging, I can have 3x squared cos of 3x minus, this will be 3x cubed sine of 3x. Taking out a common factor, which is 3x squared, then this will be 3x squared into, here I'll be left with cos of 3x minus x sine of 3x. That is what I'm going to get when I differentiate x cubed cos of 3x. Let's get another question. We're given y is equals to 5t sine of 2t. So differentiate y with respect to t. I'm going to get dy over dt is equals to, this will be, keep this one constant, which is 5t. Then differentiate this, it will give me multiply by 2 cos of 2t, and then keep sine constant, sine of 2t, multiply by 5. Then rearranging it, no, I don't need to rearrange this. This will be dy over dt is equals to, what is common here, it is 5. So this will give me 5 into 2t cos of 2t plus sine of 2t. That is what you're going to get when you're differentiating that question. This is the solution when you're differentiating y is equals to 5t sine of 2t. Another question, which is the last one. Skip for good. I'm a very colorful person. I like using colors. Okay. Now, let's say you have y is equals to e to the power 3t sine of 4t. Right? They want you to differentiate this. Now, when you differentiate this, this will give you dy over dt. This is equals to, keep this one constant, which is e to the power 3t. Then differentiate sine of 4t. I'm going to get 4 cos of 4t. And then plus. Differentiate this. I'm going to get 3 e to the power 3t. Then sine will be constant, which will be sine of 4t. Right? And then from there, I can take out common factors, which is e to the power 3t. Then I'll be left with 4 cos of 4t plus 3 sine of 4t. That is my solution when I differentiate that.